Good afternoon. For this assignment, you will be solving more radical equations and applying principles of radical functions and equations. So first, there's just this one graph and some functions here, actually a radical function, a linear function, and there's just some questions about it. It's similar to what we did in class, and I said I'd include this in the assignment. So just interpreting the graph and discussing what that has to do with the functions or the equation you would write, right? Then there's just two radical functions for you to solve. Now I chose these specifically because these should be easier to solve. So actually, I know I told one of the classes that you won't have to solve and check for extraneous solutions, but in this case, you will. I just made the solution the question, so it's not that complicated. The x's cancel out, so doesn't become a quadratic actually. So that should be a little simpler. You know, if it's a messy quadratic, then it's harder to check for extraneous solutions. So this should be a little better. And I will solve one up here as an example. So up here we have square root of x plus 7 plus square root of x minus 8 equals 5. So the first step is to move one of the square roots to the other side. So you can have the square root second, but I like to leave the square root in front even though it's a negative there. But you could also write it as 5 minus x square root, 5 minus square root of negative square root of x minus 8, all right? Now that there's a square root on both sides, we can square both sides. So on the left side, it's fairly straightforward. It's x plus 7. X plus 7. On this right side, remember, we're distributing it, right? We're multiplying this by itself, so we fall. So if you think through it, the first term times itself will just cancel out the square root. Now the middle term, I'm gonna write some extra notes, right? We're multiplying these two together. So get negative 5 square root of x minus 8. But remember, the next term is the same thing. So what we do is we simply multiply by 2 here. So we get minus 10 square root of x minus 8. Then the last term, it's 5 times 5, so that's 25. Right? So again, if it's squared, you simply double that middle term. Okay, so I'm going to simplify, so I'm going to combine like terms. We have x, let's see, 25 minus 8 is 17. So we're going to subtract x and 17, so the x's cancel out. We get negative 10 equals negative 10 square root of x minus 8. And again, these should all simplify a bit more readily. So we can divide by negative 10. So we get 1 equals square root of x minus 8. Now we just square both sides. You get 1 equals x minus 8. So x equals 9. Okay, so we just check our solution. Just plug this into the original equation. Make sure it's the original equation. So square root of 9 plus 7 plus square root of 9 minus 8 equals 5. So that's square root of 16 plus square root of 1 equals 5. 4 plus 1, which is 5, so it does check out. So this is a valid solution. It is not extraneous, and we have a solution for our equation. So that's how we solve these equations with this extra number. So when you square it, it is a little more complicated, but as you can see, they are still solvable. And so please solve that, and make sure to answer the question about the graph. I hope the graph shows how there could be applications for functions like this. Like if you have two different functions and you want to find where they intersect, in other words, when one value changes from less to more, that can be very useful in a lot of applications and in science and engineering and other fields, including business. Anyways, just do your best on that. Please ask if you have any questions, and I will talk to you next time.